Good morning. Welcome to another edition of A for A levels. Today we're going to go through physics, May, June 2020, paper 1-1. Let's go. What is a reasonable estimate of the kinetic energy of a car traveling at a speed of 30 meters per second? Car will be in the region of about 1,000 kilograms. Okay, so half mv square. Just take v square first, which will be 900. So if you take car is 2,000, then this will be about times another 1,000. So it will be 100,000, 900,000. So it will be close to a million. Yeah. The frequency F of vibration of a mass M supported by a spring with spring constant K is given by the equation. By the way, first question is always about estimation. Where C is a constant which has no units. What are the values of P and Q? Mass M, frequency F. So F will have, F will have a unit of second minus 1. M is mass, spring constant is K. K is Newton per meter. Newton is kilogram meters per second negative 2 times M negative 1. So K will be kilogram second negative 2 times M, which is kilogram. Oh, kilogram P. Of P. So K, K the power of Q. So P equals minus Q lah. Minus Q. Minus 2, Q equals to minus 1. Q equals to half. P equals to minus half. Okay, B. Okay, next. The power produced by a force moving an object is given by the equation shown. Work over time, force times time. Which quantities are scalars and which are vectors? Okay, you need to know what are vectors and what are scalars. Displacement is a vector, so A is out. Power is a scalar. Work also scalar. Displacement force, this one is okay. Power force is a vector, this is out. Work time are scalars. Power is a scalar, so this out. Answer is B. Cathode ray oscilloscope displays a square wave as shown. The time-based setting is 0.2 milliseconds per division. What is the frequency of the wave? Okay. So this is the frequency. This is the period. Period 1, 2, 3, 4, 5, 6. So T is equal to 0.2 times 10 negative 3 times 6 is 1.2 times 10 negative 3. So F equals to 1 over T, 1 over 1.2 times 10 negative 3. Divided by 1.2. 5 over 6.83. So it's 830. B. Oh, a lot of B's. A measurement is taken correctly, but with a ruler at a significantly higher temperature than that at which the ruler was calibrated. The higher temperature caused the ruler to expand. What describes the effect of measurement caused by the higher temperature and how the measurement may be improved? Okay, A, the measurement will be subject to random error. Okay, wrong. It's not random error. It will be systematic error. Systematic error is an error that is always larger or always smaller. Huh? So random is either can be larger or smaller. The measure will be subject to random error. This is also wrong. Such a systematic error, yes. The measurement can be made more accurate by taking the average several repeated measurements. No, only random error will do that. The measure will be subject to a system where the measure can be made more precise by taking the average of several repeated. More precise. It's more accurate. Okay, more by taking average of several repeated measurements. Okay, this is the most appropriate solution. The velocity of an electric car changes as shown. What is the acceleration of the car?
Recording in progress.
Okay, in this question, acceleration is the gradient. So the gradient is rise over run. So the rise is 105. 105 here. 4. So about then 105 or 4 about 26. Okay. Okay, question 7. Okay. Oh, wait a minute. I just noticed something. This is not the solution. It is in kilometers per hour. So what you need to do is you need to change kilometers per hour, meters per second. Okay, answer is 7.3. Okay, that's it. Sometimes you have to be careful about the units that are used. A projectile is fired from point P with velocity v at an angle of theta to the horizontal. It lands at the point Q. The horizontals are from P at after time T. The acceleration of free fall is G. Air resistance negligible. Which equation is correct? You can either memorize the formula for the range, or you can work it out. This is V sine theta. It's V cos theta. Okay. So taking vertically, S equals ut plus half at square. Okay. So S is 0. Displacement, vertical displacement, V sine theta t plus minus half gt square. So you have t v sine theta minus half gt. So basically you take the second t, not t equals 0. Huh? T equals to 2v sine theta over g. So this is the time taken. So distance is speed over time. So r equals to speed. Speed is v cos theta times the time times 2v sine theta over g. Okay, that one. Hey. Minus half gt square vt cos theta vt sin theta vt cos theta. Vt cos theta, there seems to be a problem. Okay, correct. So it's basically Vt cos theta only. This one. In terms of T. A car accelerates from rest in a straight line with constant acceleration. Which graph best represents the variation of momentum P of the car with the distance S traveled by the car? So obviously a lot of students will just memorize. Constant acceleration. So P equals mv. P equals to mv. We want to find a relationship between from rest. So V from the equation V square equals U square plus 2AS. U will be 0 square root of 2AS. So P will be equals to M square root of 2AS. So basically the graph of P to S is a square root graph. A square root graph. Square root graph will be this square root graph. The resultant force F on the raindrop of mass M falling with velocity V is given by the equation F equals mg minus kv square. Where k is a constant and g is the acceleration of free fall. What is the velocity of raindrop when it reaches a constant terminal velocity? Terminal velocity, what is the velocity? Okay, correct. So the velocity when F is 0, resultant force is 0. So mg equals to kv square. V equals square root of mg over k. Okay. Stationary toy gun fires a bullet. Which statement about the bullet and the gun immediately firing is not correct? Not correct. Okay, not. The force exerted on the bullet by the gun is the same magnitude as the force exerted on the gun by the bullet. Yes, this is correct. It's Newton's third law. The force on the bullet by the gun is in the opposite direction of the force exerted on the gun by the bullet. Yes, Newton's third law. The gun and the bullet have the same magnitude of momentum. Yes, magnitude. The kinetic energy of the gun must equal the kinetic energy of the bullet. Okay, yes, not necessarily so. So answer is D. Next question. A wooden block rests on the rough surface of a board. One end of the board is then raised until the block slides down the board at a constant velocity V. What describes the force acting on the block when it's sliding with constant velocity? Frictional force. Frictional force will be upwards against the direction of motion. Resultant force on the block will be 0 because it is constant velocity. T. Which statement best describes a couple? A pair of forces of equal magnitude acting in opposite direction which produce rotational motion but not translational motion. Not necessarily so. A pair of forces equal magnitude acting in opposite direction which produce translation but not rotational motion is definitely not. A pair of forces of equal magnitude acting in the same direction. Not same direction. So it's opposite direction. A pair of forces equal acting in which produce rotation but not. Oh, okay. Not translational motion. So this is the best answer. Okay, question 13. A uniform rod XY of weight 10 Newton is really hinged to a wall at X. It is held horizontal by a force F acting from Y at an angle of 30 degrees to the horizontal. As shown, what is the value of F? So it is a triangular of force already. You can use moment, so I'll decide to use moment. So at this point, F sine 30 times the perpendicular distance, I put 2L equals to 10 times L. Cancel. So sine 30 is half times 2, so F equals to 10. Okay, that's it. The four combination of vectors are shown, each representing all the forces acting on an object. The forces on all act in the same plane. The object is in equilibrium. Which combination of vectors could represent the forces acting on the object? Equilibrium. Keyword is equilibrium. So it must be able to make a triangular of force. D looks like the nearest by sight. D looks the nearest. I think it should be D. So answer is D. A is out. B is out. C is a bit out. So D is the most accurate. A rectangular metal bar exerts a pressure of 15,200 Pascal on the horizontal surface on which it rests. The height of the metal bar is 80 cm. What is the density of the metal? You can use rho Hg. So pressure is 15,200. Rho times H. H is 0.8 times 9.81. Okay. 15,200 divide 0.8 divided by 9.81. 1900. That is the nearest into two significant figure. Okay. Okay. Question 16. A mass attached to the lower of a spring bounds up and down. At which point apart the mass do the gravitational potential energy of the mass, the elastic potential energy in the spring, and the kinetic energy of the mass have the highest value. GP will be the top. So it's either this or this. Kinetic energy highest will be the center. So C answer. A block of weight 80 Newton is pushed a distance of 60 cm up a slope. Inclined at 30 degrees to the horizontal, there is a frictional force of 25 Newton between the block and the surface of the slope. What is the work done against the gravitational force and the work done against the frictional force? Gravitational force is mgh. Mg is 80 times 0.6 sine 30. So this is 24. Frictional force is 25, so work is force times distance. Okay, B. Ball is dropped from rest and falls towards the ground. Air resistance is negligible. Each graph shows the variation in speed of the height of ball above the ground. So the formula is V square equals to U square plus 2GS. So it is height and speed. So U is 0. So S would be H. It started as H now. So S equals to V square over 2G. S is basically the height. The height is H, which is the height that is dropped, minus S. So height H equals to H minus V square over 2G. So this minus V square over 2G is a quadratic. The answer is C, quadratic graph. So is C. Power is transferred through a machine as shown. What's the efficiency? Following the formula, it is output over input lah. P over P over D. Okay. Okay, next question. Question 20. A tensile force is used to extend a sample of material. The force then removed, the variation restraint on the applied stress is shown on the graph. Which point of the graph could represent the elastic limit? Elastic limit doesn't follow Hooke's law anymore. Okay, it's very clear. B. Tensile force applied to an unstretched rubber band, causing it to stretch. The tensile force is then removed. Which statement about the rubber band must be correct? Must be correct. Okay. If the rubber band stretches elastically and plastically, all the work done by the force is converted to thermal energy in the rubber. No. No. The rubber band stretches elastically, it obeys Hooke's law. No. Rubber band not necessarily obey Hooke's law. If the rubber band stretch elastically, the gradient of the force action graph represents the work done. Gradient, no, not work done area. The rubber band stretches plastically, the rubber band will be longer after the force is removed than it was before the force. This is definitely true. So the contention is B. For a rubber band, it doesn't necessarily obey Hooke's law. The sound wave reduces in intensity but maintains a constant rate as it travels through air. Which statement is correct? Changes between one particle and the next particle. Constant frequency. Intensity means the amplitude is less. Changes in this intensity, reduced intensity, that means the amplitude changes or the displacement changes. Okay. So the answer is A, very clear. The graph shows the variation in time of the displacement of electromagnetic wave at a point. The wave is traveling in a vacuum. What is the amplitude and what is the wavelength of the wave? Amplitude is 3. Wavelength have to count. T equals to 20 times 10 to the power negative 6. V equals to F lambda. Lambda equals CO frequency. 3 times 10 negative 8 times 20 times. This one over T. V equals F lambda. Oh, this is 10 to the power 8, sorry. Negative 6. So this is 60 times 10 square. 6,000. So it's A. A long glass tube is almost completely immersed in a large tank of water. A tuning fork is struck and held just above the open end of the tube as it is slowly raised. A louder sound is first heard when the height h at the end of the tube above the water is 18.8 cm. A louder sound next heard 56.4 cm. Speed of sound in air is 330 meters per second. What is the frequency of the sound? V equals F lambda. So if you can find lambda, you can find the frequency. So first, harmonics. Second, harmonics. Okay. So half lambda equals to 56.4 minus 18.8. Lambda equals to 10, 20, 27.6. Times 2. Okay, so 75.2 cm. So F equals 330 over 0.752. Over. Okay, good. A source emitting sound of a single frequency travels at constant speed directly towards an observer. The source then passes the observer and continues to move directly away from the observer. The velocity of the source remains constant. Which graph represents the variation with time of the frequency of the sound heard by the observer? Okay. So the observed frequency when it's moving towards the observer is larger. When it's moving away, it is smaller. So if it's at a constant speed, that means the observed frequency will be constant. Speed. Okay, what are the names of the electromagnetic waves that have wavelength in a vacuum of 100 picometer and of 100 micrometer? Always this you have to remember. Light is wavelength 400 to 700 nanometer. So it's 4 times 10 negative 7. 7 times 10 negative 7 nanometer. So pico is 10 negative 12. So this is 100 is 10 negative 10. Micro is 10 negative 4. Micro will be infrared. Okay, 100 micrometer will be infrared. And 10 negative 10 will be X-ray. X-ray is not in the region of gamma yet. My pick will be X-ray. Okay. Gamma will be 10 to the power negative 12. Okay. The diagram shows a string stretched between fixed points X and Y. There's a stationary of the string. The solid curve shows the string in a position of maximum displacement. The dashed curve shows the other position of maximum displacement. The straight line central dash line shows the mean position of the string. Point S on the string is directly above point P. Point T on the string is directly below point Q. Which statement is correct? A short time later, point R on the string will be displaced. No, this is not. No. Point S and T of the string move in opposite direction. Yes, the distance between P and Q is one wavelength. No, it's only half. The 2 points on the string that are equal distances from point R vibrate in phase. No, they're 180 degrees out of phase. So B. Which statement must be true for diffraction to occur when a wave passes through a gap? Wave has a long wavelength is the most probable answer. But if it's too long, sometimes there can not be also. Huh? Must be true. Must be true. So for diffraction to occur, wave must be a progressive wave, not a stationary wave. Light of single wavelength is incident normally on two slits that are 0.2 millimeter apart. Interference fringes are observed on the screen that is 5.4 meter away from the slits. The distance between successive bright fringes is 12 millimeter. What is the wavelength? Lambda equals to AX over D. A is the distance between the two slits. X is between two fringes. D is the distance between the slit and the fringe. For 4 nanometers. Okay. Okay. A diffraction grating and a screen are used to determine the single wavelength lambda of light from a source. What is essential feature of this experiment? Formula is d sine theta n equals n lambda. Okay, because diffraction angle must be measured for at least 2 interference to determine the single wavelength lambda. This is a very, very tricky question. So sometimes it's not only about what this is correct. Curve screen must be used is correct. light wave incidence grating must be coherent. Third order intensity maximum must be produced. This is not necessary. Huh? Essential feature. Essential. So for this essential, it must be coherent. You can find the wavelength by other means. But essential, if it's not coherent, the other two would be, the other two answers will not be relevant. Small charge Q is placed in the electric field of a large charge Q. Both charges experience a force F. What is the electric field strength of the charge Q at the position of a large charge Q? Oh, this is very, you got to read properly. This is Q. This is Q. Of the charge Q, this charge, electric field strength here. So as F over Q. So all Q. Okay. Force, electric force of a charge. It's the electric field strength of the charge Q. A charged particle in a vacuum between two horizontal metal plates as shown. The acceleration of the particle is 7.15 times 10 to the power 11 meters per second square. Downwards, the particle has a mass of 3.34 times 10 negative 27. Okay, what is the charge on the particle? Downwards. Yes, a mass of 3.3. So F equals MA. So what is F? F equals to EQ. So QV over D. It's also F. Q equals to MAD over V equals to M. 3.34 times 10 negative 27 times 7.15 times 10 11 times 10 negative 2. Okay. (1.6 times 10 negative 19). So is it positive or negative? So it's downwards. Downwards, electric field strength is downwards. Electric field strength is downwards. So if it's downwards, it's a positive charge. What are the direction of flow? The rate of flow of electrons through the resistor R. Y to X. So these two. I equals to Q over T. Times 10. Read. This is -3 divided by 1.6. The number of electrons. 2 times 10 to the power 16. Okay, see. 34. Which graph best represents the way the current I through a filament varies with the potential difference V across it? So this is a very common question. This is also learned in IGCSE. So answer is B. Resistance increase as the current increases. A cylindrical metal wire X has resistance R. The same volume of the same metal is made into a cylindrical wire Y of double the length. What is the resistance of Y? So you have A times L is the volume. Also B equals to double the length 2L. That means the area is half A. So the resistance is rho A over L initially. Now becomes, the resistance becomes rho A over 2 over 2L. So it becomes 1/4 rho A over L. So it's 1/4. Formulas wrong. Formula wrong. Formula wrong. Rho L over A. Rho L over A over 2. Rho L over A. So it will be R. Okay, luckily got no 1/4 R. I was making a mistake already. A cell of electromotive force E and internal resistance R is connected to a resistor or resistance R. A maximum power P can be deceived by the resistor without overheating. What is the maximum value of E if the resistor does not overheat? So P equals to I square R. I square R. E equals to I R plus R. So from here, I equals square root of P over R. D. 37. Three identical resistors can be connected together in 4 different ways. Resistance of 2 of these combinations are 4 and 9. What are the resistance of each individual resistors? Identical. Maybe it is 3, 4, and 9. So let's say it's 3, 9 is possible. 3, 6, and 6, 6, 6. I think it is 6. This is 9. 4. 18. It seems to be quite a challenge. 6, 6, 6, 6, 6. This is 9. What 4? 1 over 6 plus 1 over 6 plus 1 over 6 is 1 over 2. It's not 4. One over 6 plus 1 over 6 plus 1 over 12. Okay, correct. 6. In the circuit shown, a battery of negligible internal resistance connected in series with a pair of fixed resistors R1 and R2. The circuit is to be used to test whether the electromotive force of a particular cell is 1.5 volts. Cell is connected between terminals X and Y in parallel with R2 and in series with the galvanometer. Which statement about the test is correct? Any non-zero reading means the cell has an EMF. Wrong. The battery does not need to have an EMF of 6 volt. Which battery? The cell can be connected either way around between X and Y. This is correct. It does not need to scale or calibrate in amperes. Just need to be 0 near. Cell can, oh no, the cell cannot be connected in either ways, or else it will be out. This one's out. It must be connected in this way only. The battery needs to have an EMF of 6 volts, then it can. So the answer is this: does not need a scale, it does need to be 0 only. An element has 2 isotopic forms. What are the nuclear arrangements of these 2 isotopes? They are different nuclear numbers and different proton numbers. They are different nucleon, same proton number. This is the meaning of isotopes lah. It's very clear. Chemistry also has. A hadron has a charge of plus E, where E is the elementary charge. Which combination up and down quark? So up and down quarks could form this hadron. Up is plus 2 over 3, down is minus 1 over 3. So it should be up and down, which is the charge of a proton. Okay, that's it. If you like this, please subscribe to my channel. If you need more explanation, you can email to me or put a comment. Thanks.